y'all talkative this morning. Y'all all right? Y'all ain't sick, are you? What? I didn't hear what he said. It sounded like you said starting getting people for the drought. Which drop. People don't drop my class. It's impossible to drop my class. Oh well. Now let's see if it works. Let's go ahead and start a problem. I got a couple of problems for you. Check these, Miss Hildebrand, and see if they match up with yours. If not, give me yours again. Just see if they're like yours.
Yep, exactly it.
Okay. Exactly the numbers?
No, not the numbers,
okay.
But
well, let's this one was given to me yesterday, and we'll do it first. Go through the difference quotient. F of x. While y'all are writing, I'm going to see if I can see if the board works. F of x is equal to 9 over x minus 9. Now you're going to have to reach deep into your algebra to do this one. Put it in the difference quotient and find the derivative. Yeah, just come on in whenever, that's fine. Sleep late, get breakfast.
Hey, there's a tractor.
There was a tractor.
There's a tractor.
Good. That means somebody's working. Probably had a rake or a baler behind it. I got a bale today. I got 40 acres to bale. Where was the tractor? What road?
Over here at that farm, that's the Mike Smith.
I know who that is. In Pendleton?
Yeah, just went over.
Let's see if it works. Where's mine? Sure the battery's good. Yep. No, wait a minute. Nope, don't work. So the first thing we're going to do is we're going to draw the wrong set of parentheses. We're going to 9 over big set of parentheses minus 9 minus 9 over x minus 9 all over h over what? 1. And this right here is this right here. And what do we, difference quotient, we plug in what? X plus h. Okay, so that's what your difference quotient should look like. This right here is f of x plus h. This is f of x. and this is h. So I'm just going to do this for somebody that needs it. That in the green box is f of x plus h. It's incredibly hard to write with a mouse. Sounds like a song. And magenta, this is f of x. That's easy to do because you don't change anything. You just rewrite f of x right here. So here is f of x plus h, and here is f of x over h. Now you got to reach into your algebra bag. You basically have a complex rational expression. Now, when you have a complex rational expression, I'm going to go to another page, and I'm going to make up a problem back in Algebra 2. 1 over x plus 3 over x plus 1 over 2 over 1. What is the common denominator of all of those things? Of all of these denominators? This denominator, and this denominator. Well, the common denominator of all three of those things is x times x plus 1. Okay, let me take it down further. 1 over 3 plus 2 over 7 over 8 over 1. What is the common denominator of 3, 7, and 1? 3 times 7. Okay, you see the relationship? If 3 and 7 have nothing in common, you mash them together. Okay? So these have nothing in common. Well, somebody can say, well, x is in common. Not necessarily, because this x is what? By itself. This x has a 1 beside it. All right? Now, if this was x squared and this was x, then the common denominator would be x squared. But since you have two different animals here, just like here, you have to what? Put them together. So what I would do, let me get out of the, if you was to do this one, it would be x times x plus 1 over 1 over x times x plus 1 over 1. Now what's x times x plus 1 over 1 over x plus 1 over 1? 1. So you could do it that way. And over here you would do 3 times 7 over 1 and 3 times 7 over 1. And of course, the 3 would cancel here and you'd be 7, and so on. The x would cancel with this x, you get x plus 1 right there. The x plus 1s cancel, you get 3x. So now we're going to go back to the problem. The common denominator here is x plus h minus 9 times x minus 9. So work that out. Notice how long it'll take me to write it with this mouse. X plus h minus 9. And I'll put that in brackets so you can see that you multiply them together. X minus 9 over 1 over x plus h minus 9 times x minus 9 Now you can do this because you're not changing anything. You're basically multiplying the problem by 1. You could multiply by star over star if you wanted to, but star wouldn't help you. But multiplying by anything over itself is multiplying by 1, so it really doesn't matter. Good gracious, y'all all sick. Y'all need some orange juice and some chicken noodle soup or something. All right. Now what? Well, multiply this by this. And I'm going to put a baby step in here for you. It'll take me forever to write, but 9 times x plus h minus 9 times x minus 9 over 1 times x plus h. Can't write. X plus h minus 9 minus 9 times x minus h minus 9 times x minus 9 over x minus 9 all over h times x plus h minus 9 times x minus 9 over 1. Now what you're going to see is what? The x plus h minus 9's cancel, and the x minus 9's cancel. And now rewrite that. Clean it up.
You have a work email.
Sorry.
You have a work email.
Must be the desk. Y'all supposed to go crazy and have a heart attack. Nope. Okay, how do I get this thing up? There we go. So that's going to leave us with 9 times x minus 9, right? 9 times x minus 9 minus, I'm going to put a big set of brackets here because of what? That guy right there will make your life miserable. So you need to make sure you do it right. That's going to give us a 9 times x blah blah blah. 9 times x minus h minus 9 over h times x plus h minus 9 times x minus 9. All right, now clean up the numerator. 9 times, 9x minus 81 minus 9x plus what? 9h. Minus plus what?
81.
And I'm just going to put h times, and I'm going to put a squiggle line. That means all of this stuff. Okay? That's a squiggle. And because the most important is what's going to happen up here. Oops. Your 9x's are going to cancel. Your 81s are going to cancel. Look at there, 9h, and that h cancels with what? That h right there. So we're left with 9 over x plus h minus 9 I'm making sure I wrote it down right. X minus 9. Now we just bring in our limit that we learned as h approaches 0. There's only one h, so that goes what? Goes out. And we got x minus 9 times x minus 9, which is? So we got 9 over x minus 9 quantity squared, which is equal to 9 times x minus 9 to the negative 2 power.
Why did you cross out the h on the first, in between
We're
x
about
and negative 9? Why did you cross out h?
Right here?
Yep.
That's 0. H is equal to 0, or approaching 0.
Are you sure the numerator is 9? It's not negative 9? It's just negative 9.
Where?
Because you multiplied it, you multiplied by
Oh yeah,
x
yeah,
minus-
negative, thank you. I dropped it. I guess I just dropped it. Oh, there, right there. There it is. There it is. No.
It's because you put x minus h above that, and it's x plus h.
Okay, let me. Where? Right here.
Yeah.
Negative 9 times negative h is
No, but it's
positive
supposed to be
9h.
plus.
Oh, it's supposed to. Oh, okay. Thank you. Thank you. And that makes that negative. Now, some of you that remember your calculus, let's check this. Let's go down here. And if you remember your calculus, and we'll do this after we finish this test, we'll go into the derivatives. But first of all, you would rewrite this. If you wanted to find the derivative of this, you would rewrite it as 9 times what? X minus 9 to the what? Negative first power. And using the chain rule, negative 1 times 9 is what? Negative 9. X minus 9. Negative 1 minus 1 is negative 2 times 1, which is derivative of what's inside. And you get negative 9, x minus 9 to the negative what? 2. So, let's count the steps. 1, 2, 3, 4, 5, 6, 7. 1, 2. You learn to appreciate calculus now that you know what it does. It cuts out about 5 steps. Yes, ma'am.
Can you go over that shorter one again? I'm sorry.
The short one. This one?
Yeah.
Okay. This right here, you don't like that fraction because fractions don't work good. So you bring this x minus 9, and that's to the first power. You bring it upstairs. And when you bring it upstairs, it becomes this. And then with derivative law, which we'll get into in the next unit, the basic derivative law, well, this is the chain rule, but it follows the basic rule. This times this is negative 9. Bring down what's there. And then negative 1 minus 1 is negative 2. And then the derivative of what's inside is 1. And that's your answer. 9, negative 1 doesn't change anything. So negative 9 times x minus 9 to the negative second power.
Like you subtract the 1.
That's the exponential law of calculus.
Okay.
Yeah, that's the rule. And what I'm doing is I do these problems today. I'm going to do this, and then I'm going to show you the derivative, how to do it, and then that way your mind will start getting into that calculus mode. Some of you that's had this calculus before, you'll start to make the transition between algebra plus limits, and then next unit we'll put those two together, and instead of doing all this, we'll just do this, and you'll be in calculus. And that's the transition. Yes, exactly. The shovel and the backhoe. Good analogy. You're a winner. All right, let's try this one. This was given to me yesterday also. F of x is equal to the square root of x plus 6. Now, let me show you one thing before we start this problem. Here, I'm going to take my handy dandy green highlighter and I'm going to highlight this whole area right here. This is in Algebra 2 and it's called complex rational expressions, where you have to multiply through by the common denominator. That's where you had to reach back in your algebra. Well, in this problem, you have to reach back into your algebra, rationalizing not the denominator, but the numerator. So you have to multiply by the conjugate. Conjugate of a plus b is a minus b. So I'm kind of reviewing back, kind of throwing you back into Algebra 2, because that's where you have to dig here, where in the previous problem you had to dig into the complex rational expressions. This one you have to dig into rationalizing the numerator. So knock yourself out. Dang old, I'll start you off. Let's see, f of x plus h, that means I got to rewrite my problem and put a big set of parentheses, plus 6, that's f of x plus h, minus f of x, well, f of x is just the whole thing, so I can't mess that up, except with a mouse, over h. And I'll take my handy dandy highlighter and I'll highlight this and that. So that means that I got to plug in x plus h there. Okay? Send them an email saying that so that's going to give you basically this. There's nothing you can do with simplifying these unless you multiply by the conjugate. This is a minus b, right? So I'm going to multiply by a what? Plus b over a plus b. So a plus b over a plus b is what? 1. So this, I could just, I don't know if this will work or not. Let me see. Heck no. Anyway, so I'll just rewrite this. Square root of x plus h plus 6 plus square root of x plus 6 over square root of x plus h plus 6 plus square root of x plus 6. Oops. Well, you get now, that's going to give you a minus b times a plus b, which is shortcut number what? Number 3. Difference of two what? Squares. So that means that's going to knock this guy out and knock this guy out as far as the radicals. So if you multiply this times this, that's going to give you x plus h plus 6 minus parentheses x plus 6. It's going to take the radicals away, and then you're going to distribute the x, and you're going to see things cancel, over h times square root of x plus h plus 6 plus the square root of x plus 6. And when you distribute this negative, that's going to give you x plus h plus 6 minus x minus 6 over h times squiggle, meaning all this. So now, what do you do with the 6's? They cancel, the x's cancel, and the h's cancel. And that leaves a 1 up here. So now we've condensed it down to 1 over the square root of x plus h plus 6. Did I write x plus 6? I suck. X plus h plus 6 times the square root, or plus the square root of x plus 6. This would be so much easier if I could write it with a pen. My hand's hurting. Whew. All right, so now we've done the algebra. All that stuff we used to do 9th, 10th, 11th, 12th grade. Now we apply our new friend, the limit. As h approaches 0. And that's going to leave you with, what happens to the h? It basically goes away. X plus 0 plus 6 is x plus 6. So we've got 1 over, oops, don't want to change horses in midstream. 1 over 2 square root of x plus 6. Now I'm going to rewrite that because I'm going to do the derivative here in just a second, for those of you that remember. That's equal to 1/2 x plus 6 to the negative 1/2 power. Now, for those of you that's had calculus before, let's check it. F of x is equal to, scary thing is I'm getting faster with the mouse, x plus 6. Well, we don't like radicals, and calculus don't mix. So x plus 6 to the what? 1/2 power. Bring that 1/2 out front. Bring down what's in the parentheses. And negative 1/2 minus 1, which is 2/2. Okay, something's wrong. What did I do wrong?
Please do.
Where's my notes? Where's my notes?
Should just be one half.
Should just be 1/2 minus.
Huh?
You went ahead and.
Oh, this
put
is
the negative.
1/2. Okay, it's positive 1/2. I knew something was wrong. There we go. And that's equal to 1/2 x plus 6 to the negative 1/2 power. Does that look familiar? Go away. 1/2 power. You don't work. There. And look at there. Oh my gosh. We got the same answer. We are so good. Again, here's the shovel, and here's the backhoe. Some of y'all don't even know what a backhoe is. It's your parents' fault. All right, so 1, 2, maybe 2 and 3 right there. 4, 5, 6, 7.
What is all this song?
Huh?
What is all this song? What is this called?
We're working toward this right here, down here, derivatives. So therefore, you can find the tangent line to any curve. In which, in business, you're going to be finding any point on a curve, especially with a profit curve or with a losing money curve. And you need to find that point. And when you find that point, you need to find the tangent, because the tangent line is the rate of change at that point. And rate of change, let me put it to you this way. You're making widgets. Okay, that's what business people talk about, widgets. It's just a form of something. And at a certain point in time, you're making profits. But what if you sell 10,000 widgets? Boom, you pick a point, 10,000 widgets. And then at that point, you can put a rate of change, which is the tangent line at that point. So you can go 10,000 to 10,005, or you can go 10,000 or 9,000, whatever. In other words, you can work with just that one point. And you'll get into that when you get into your business. If for those of you that are in the business, when you get into business and marketing, you're going to get into that rate of change at a point in time. Calculus is nothing but finding out a point in time. Finding out all the information you can find out. And that's what we're working on. All right? So this is the transition. Algebra and calculus, algebra and limit. Algebra plus limit is equal to calculus. And this is the calculus right here. All right, let's do nerd. This one was given to me yesterday also. F of x, and this is kind of simple, similar to the last one, is equal to 4 over square root of x. You know, I've about come to the conclusion, if you don't know computers and you don't know how to work computers, you shouldn't take an online class. Don't y'all think? I think it should be a prerequisite. You should be in, you should have 2 or 3 computer classes before you take an online class. I've got people still can't get on them, My Labs Plus, 2 weeks into the semester. I got a good friend, he's a surgeon, and he bought a tractor. And since he's bought that tractor, he's wrecked it like 5 times, almost had it turned over on him. Some people shouldn't be on tractors, and some people shouldn't be on online classes.
That's an analogy accepted.
Yeah, I mean, honestly, some people shouldn't be driving cars. Some people shouldn't procreate either. After about 5 kids, I think you need to work on that. So we're going to rewrite this 4 over square root of what? Big set of parentheses minus 4 over square root of x, because you just rewrite it, over h over 1. Now a lot of people say, why do you write h over 1? Because this is a complex rational expression. You're going to have to multiply by the conjugate, which is these two together. Well, I'm sorry, the common denominator over 1 over the common denominator over 1. So that's why I do that. So x plus h goes here. And now we've got our common denominator. So I'm going to take my handy dandy parentheses here over parentheses here, and I'm going to put square root of x times the square root of x plus h over 1 square root of x square root of x plus h over 1. Now that's going to give us 4 times the square root of h minus 4 times the square root of x plus h. Because what happens to the other one in each of these? What happens to the x plus h is right here. And what happens to the x? That cancels. So that's what you left with. Over h times square root of x times square root of x plus h. I'm fixing it for some of y'all that can't see the bottom. There you go. All right, now you need to simplify it. Well, we got to use the conjugate. This one uses both the common denominator and the conjugate. So the conjugate of 4 square root of h minus 4 square root of h plus x plus h is what? Well, you can use 2. You can use 4 square root of h plus 4 square root of h x plus h, or you can just use the square root of h plus the square root of x plus h. And that way you don't have to do double the math. Okay, because you have to square 4 and you get 16. They all cancel out. So I'm just going to, yes?
I still don't understand how you got to that one on the bottom.
This right here? Okay, well, I'll put a baby step in here for you. And what I'll do, let me see if I can do this. Nope. Let's try this. Now just bear with me a second. Well, no, that isn't what I want to do. No, it's not gonna let me do it. But anyway, I was gonna try to do it. Forget it. It's impossible to do things on this thing. I just might as well forget it. Yes, ma'am.
Would you not be taking the conjugate in this case as well? You've got.
Right here. Yes, we're going to.
So you do it in two different steps?
Yeah.
You pull the 4 with the conjugate?
You don't have to. I was just saying that.
Oh,
You don't
okay,
have
so
to.
you just pull the 2 radicals?
Yeah.
Okay.
Yeah, I did the radicals because you just make the 4 into a 16. I mean, that's the difference. Let me finish this baby step right quick. I'm going to rewrite my problem. 4 over the square root of x plus h. I'm going to leave a space there. And then 4 over square root of x over h over 1. Now I'm going to take my blue marker and I'm going to multiply. I'm going to take this right here and I'm going to distribute it. And that'll give you the square root of x, square root of x plus h. I have to do this in my algebra classes, so I'm used to it. That's why I call it a baby step. Square root of x, square root of x plus h over 1, square root of x, square root of x plus h. It's a whole lot better though when my pens work. Sucks when I'm using the mouse and get carpal tunnel up here. Okay, look like the guy, the mutant on Total Recall.
Shouldn't that be the square root of x then?
Yeah. Well, no, right here.
No, at the bottom under your first step, where you rewrite
Your next step,
Here.
where we're about to take the conjugate from.
4x.
No, down.
You got 4, 8.
And below
Yeah,
that.
square root of x. Yeah, I'm sorry. Right there.
Yeah.
Sorry.
That's probably where I was.
Well, I'm sorry. I just decided to put a h there. I'm sorry. There we go. Square root of x. All right, sorry. And anyway, what happens to the x plus h's? They cancel, and you're left with square root of 4x. The x's cancel, that'd be x plus h. And then this comes out to be this. All right, now I'm going to do my conjugate. And I'll do it in red. So I'm going to do square root of x plus the square root of x plus h over the square root of x plus square root of x plus h. Okay, you can factor that 4 out and pull it out here, and then you'll have 4. What you'll have is just factor a 4 out right here, and you'll have this. And that 4 will be gone. You don't have to do this. I'm just doing it to show you why I'm doing it by x plus h. So in the whole outcome, you're going to get 4, and then I'm going to put a baby step in here. Square root of, if you use shortcut number 3 here, this is a minus b, a plus b, which is the square root of x, quantity squared, minus the square root of x plus h, quantity squared. And what happens to the square and the radical? That cancels with that, and that cancels with that. So in the end, you're left with 4 times x minus x plus h. So 4 times x minus x plus h over h square root of x square root of x plus h times square root of x plus square root of x plus h. Yes, ma'am.
You say you don't distribute the negative, the minus, you don't put that to the h? On the, when you're getting rid of the square root.
Yeah, be minus h right there.
Okay.
Sorry.
Can you back up to when you were writing in red?
Yes. What you need?
Do it again.
Okay.
I don't know what.
All right. I factored out a 4 here. You don't have to do that, but I did because that people wonder why I'm using just x plus h. If you factor out a 4 with this 4 square root of x minus 4 square root of x plus h, pull the 4 out, you're basically doing the conjugate of this right here, which is square root of x minus square root of x plus h. Well, what's the conjugate of the square root of x minus square root of x plus h?
Those are multiplied on the bottom. Why would you do that?
Whatever you do on top, you got to do on the bottom. You got to make a 1. This is 1. Anything over itself is what?
So you're
1.
trying to get rid of all
I'm
of
trying to get rid of the radicals at the top. That's what I'm trying to do.
Okay.
So 4 times the square root of x plus square root of x minus the square root of x plus h. Multiply that by the square root of x plus the square root of x plus h. You get this. And what happens, the squares, using shortcut number 3, those of you that don't know shortcut number 3, you better takes those out and you're left with this. And you think, at this point, you're thinking, oh my God, I don't know how to do this. No, because the h, our best friend, the h, is going to take care of a lot. What happens here? What happens to your x's? They cancel. What happens to this h and this h? It's canceled, but there's a negative 1 right here. Don't forget.
So wait, when you're multiplying by the conjugate, what does that solve into?
Okay, hold on. We got to review the conjugate because some of y'all, I'm getting a lot of funny looks from about 3 or 4 of y'all. All right, whenever you have a plus b over star, okay, it could be anything. It could be x minus 1 or it could be 4 minus x. If you want to get rid of the radicals up here, all right, let's say that a and b has radicals. You use the conjugate. And the conjugate of a plus b is what? A minus b. The conjugate of a minus b over star, whatever, would be a plus b. But you can't just multiply by the top because you got to multiply by a factor of 1 because 1 is the multiplicative identity. 1 doesn't change anything. So what you're doing is multiply by the top and the bottom by a minus b. Now, what that does, it's just like completing the square. You manipulate using the shortcuts. Well, this right here and this right here is shortcut number 3, which is a squared minus b squared is equal to a plus b times a minus b. So that's what you're getting when you multiply by the conjugate. A plus b is conjugate of a minus b. A minus b is conjugate of a plus b. So you can rewrite this and this as a squared minus b squared. Both of these. Now, if this is a radical, if you have a radical here, then that radical goes away. And that's what you're doing. You're trying to get rid of the radical.
That's only if it's a square root.
Yeah, square root. Okay? And that's when you use the conjugate. It's when you're trying to get rid of the square root. Does that help? Does that help on the conjugate?
Yeah, but can you go back?
Yeah.
Okay, so what did you do with the bottom after the conjugate?
Right here. H times square root of x plus h
Times square root of x
times,
plus.
I got it in parentheses, yes, right there, times this. And we're going to take up with that next. Makes you appreciate what?
No.
Makes you appreciate the backhoe, doesn't it? Closing your mind. Don't close your mind. You'll be a redneck all your life. That's what I tell my daughter. Okay? Now we apply the limit. Limit as h approaches 0
So
of
on top you have 4x minus 4, no, it's 4 times.
negative 4. You have negative 4. After you finish, you have negative 4.
Okay, leave the h for a second. You have, oh, there it is. So,
Yeah, the h cancels with this h. Over square root of x, square root of x plus h, times square root of x plus the square root of x plus h. Now, I want everybody who hadn't finished it to plug in your zeros and see what you come out with. Simplify it.
so how did the 4 on top turn negative?
This negative 1 h right here.
But that was just canceled out.
No, the h was canceled out. H cancels out with this h, and that leaves the negative 1 right there because you can't cancel out a negative with a positive. This one's positive. So this h cancels with this h, and that leaves a negative 1. That negative 1 times 4 is negative 4. Now what I'm going to do here, I'm going to take this big red dot, and wherever there's an h, I'm going to put that dot, because what happens to, what's x plus 0? X. Okay, so that gives us, we apply our limit theorem, and that gives us negative 4 over the square root of x times square root of x, because the square root of x plus 0 is x, square root of x, times the square root of x plus the square root of x.
So what happened to h?
H goes to what? 0. Remember, what's happening to that distance between the first x and the second x? What's it doing? It's converging to what? 0. Now, what's the square root of x times the square root of x? How about x? Negative 4. Yeah, the square root of x squared. And what happens to the square and the radical? They cancel, so you're left with x. And the square root of x plus the square root of x, 1 box of cereal plus 1 box of cereal is 2 boxes of cereal. So that'd be 2 square root of x. What else cancels? 4 and the 2 cancels. That leaves a 2 here. And that's equal to negative 2 over x square root of x. Now, that's not the final answer, because you can rewrite it. Now, what I want you to do is rewrite it. I want one continuous term. I don't want no fraction. I want you to write it as a one term. So you have to use a little bit of manipulation there. And y'all are calculus students. One thing you're going to learn is calculus and radicals don't what? Don't mix. So change that radical into a exponential. That's a little hint. And we need to add exponents because this is multiplication. So that's -2 over x to the 2 halves. That's a 2. I can't write a little 2 with the mouse. It's hard to do. Times x to the 1/2. And that's equal to -2 over x to the what? 3 halves. And then what do I do to bring that 3 halves up? -2x to the -3 halves. Now we check with our handy dandy calculus, which we're going to get into in the next unit. And f of x is equal to 4x to the -1/2. Use our exponential rule of calculus, and that's going to be -1/2 times 4 x -1/2 minus 1. Well, what's 1/2 of 4? That's -2 x to the -1/2 minus 2 halves. Look at there. -2 x to the negative what? It kind of helps for you to see how you get this. So when you get into the next unit and you actually do the calculus, you'll be like, thank goodness for calculus. What was yours? I want to do another one of these because I still think people are kind of iffy on it. What was yours?
The ones that I asked you about?
Yes.
They were just like that.
Just different numbers. Give them to me.
Okay,
The first one.
Either radical of x plus 9.
F of x is equal to what? Radical?
Well, square root, yeah, of x plus 9.
Square root of x plus 9. All right, y'all do that one. I'm going to let y'all do this one. A little bit different. Ours was x plus 6. You do x plus 9.
On the homework, why does it refer to h as a change in x?
Same thing.
Same.
Delta, does it say delta x?
Yeah, definitely.
Yeah, delta x and h is the same thing. Think about it. Remember what's it doing? Changing x, changing x. And what was your other one?
It'll be 8 over the square root of x.
There's the other one. Let me pause. Well, there's the result. This right here is calculus. And this is algebra. 1, 2, 3, 4, 5 or 6 steps.
If you did it like the complete calculus way, how did you figure out the -1/2?
Well, anytime you have a radical, that's your radical rule. The radical rule is the square root of x to the first power is equal to x to the 1/2. Exponent over what? Index. So the cube root of x plus 1 squared would be x plus 1 to the what? 2/3 power. Anytime you have a radical in calculus, you want to change it to an exponent.
So you brought it over, but then you brought it back.
Where?
Like, cause you,
Yeah, you dropped it in front of it and then you added it back.
Where?
like you
Right
have it
there.
where your
Right here?
cursor is. Yeah.
Well, in calculus, you bring this out front. That's the 1/2. And then you subtract 1 from the exponent. You'll learn that in calculus when we get there. We ain't got there yet. We're getting there. You know why you can't do calculus? Because you can't do the algebra. That's why. Because after you get into calculus, you use algebra principles that we're going over right now. You use them in calculus. And that's the difference between an engineer and an English teacher. Difference between a business person that does calculus and a sociology major. They don't manipulate equations. They don't solve problems. And I'm sorry if that offends people, but it's true. Let a sociology major build a bridge. Nope. All right, f of x is equal to, what did you say it was? 8 over the square root of x. 8 over the square root of x. From now on, when y'all see a backhoe, y'all gonna think of that shovel.
The same answer as the other one though.
That's fine. It's the whole point of going through the method. But when we get to that unit on calculus, everybody's going to embrace that calculus now. Oh, thank you. I mean, if you want to try one, f of x is equal to x squared plus 4x minus 3. That's one that's fun.
I think they had one like that on the
Did they?
homework. There was one where you had to do
I picked
x
one.
plus
Yeah, I
h,
picked
like,
one.
cubed,
Yeah.
and it was just crazy.
I know. And the reason I did that, I didn't necessarily do it to make you get it right. I wanted you to see how, what's the word, persnickety these problems can get without the calculus. So, 8 over the square root of x plus h minus 8 over the square root of x over h over 1. Common denominator, take my handy dandy blue pen. Square root of x, square root of x plus h over 1. Square root of x, square root of x plus h over 1. And when you do that, you're going to get 8.
That just confused me.
What? Why did it confuse you?
That's the conjugate?
No, we don't do the conjugate here yet. Okay, here you got common denominator first.
Technically, you could just cross multiply, right?
Yeah, but if I did that, it would cause head to explode. All right, you got to get a common denominator. All right, so that's why I did this first. So that's x times the square root of h. I'm sorry, square root of x minus 8 square root of x plus h over h times square root of x square root of x plus h. Now you use the conjugate. I'll do that in red, times, and I'm going to factor out the 8. I'm going to do that. So that'll put an 8 right here, parentheses.
How do you multiply the reciprocal times that, I'm not the reciprocal, your function times that, common denominator?
Okay, 8 times this
Yeah,
over this. What happens to the x plus h's?
okay.
They cancel and you get the square root of x. And then 8 times this over this. Yes, distribute. Yep,
Yeah, that's what I was confused.
sorry. And I'm going to multiply by, in red, the square root of x, plus square root of x plus h over square root of x plus the square root of x plus h. Now, what's that going to give us on the top? Well, it's going to give us 8 times what? X minus x minus h. That's your final product, because you're going to get 8 parentheses, then you're going to get the square root of x quantity squared minus the square root of x plus h quantity squared. Shortcut number 3. And then on the bottom, you're going to have a cluster. H, but the cluster is going to work out because of the h going to 0 and canceling.
Okay, I'm still lost at the step I was trying to figure out. You distribute the square root of x, square root of x plus h amongst.
Here,
Can you
here.
just do that really quickly?
Yeah. 8 over the square root of x plus h, square root of x, square root of x plus h, over 1. That's 1. Minus 8 over the square root of x times the square root of x, square root of x plus h, over 1. All over h times the square root of x times the square root of x plus h. Now, watch what happens. What happens to the square root of x plus h? That cancels and you're left with what? 8 times what? 8 times the square root of x. What happens to the x's here? And you're left with negative 8 times what? X plus h. Now 8 is in common, right? So what can I do with the 8? I can pull it out, and then that leaves me with these two. Does that help?
Yeah.
Did I do that? Let's see. H, x plus h, x times x, square root of x, plus square root of x plus h. Make sure I got that right. X plus h. Okay. Now, what happens to the x's? They cancel. That one goes out there. And what happens to the h's? The h cancels with this h, but there's still a negative what there? There's still a negative 1 right here. So that negative 1 with that 8 comes out to be negative 8 on top. Let's go ahead and zero our h's out. There's only 1. Well, there's 2. So that takes that h out and that h out. So that leaves us with the square root of x, distribute it. You can distribute it if you want to or whatever. Doesn't matter. So I'll just write it out. Square root of x times the square root of x plus the square root of x. And if you distribute that square root of x, you're going to get x plus x, which is what? Oh, 2 square root of x is where?
In the front there.
Oh, right here. This is 2 square root of x. X plus x is 2 square root of x, right? Is that what you're talking about?
No, in the front, yeah. So it'll be square root of x times square root of x times square root of x.
Okay, right here, square root of x. Okay, sorry. And that's going to be negative 4 over x square root of x. That should be your answer. Okay. Now, these were 4 problems that are challenging, but like I say, they're brushing you up on your algebra skills, and they're letting you see how important the actual calculus is when we get to it. Hold on just a second. Let me shut down everything and get the roll. I'm not erasing it. I'm just stopping recording.